Okay, so this time what we're going to do is spend a little time going through how to get standardized scores in Excel. So we're going to use the standardized function to do this. We're also going to learn a couple tricks about how to make Excel do some math for us more quickly rather than to have to type equations over and over. So we're going to work with the set of data that I worked with in the previous demo. We have individuals in an ID column who have certain amounts of stress and symptoms, physical symptoms that they're experiencing. So first, let's go ahead and let's use our stress variable again. So we've seen the distribution kind of stress scores. We've done this previously with our histogram to get an idea of the data. And we can get ideas. We've also seen, is this normal? Well, there are different ways you can measure that. The descriptive output includes two important measures for normality, which are skewness and kurtosis. So here are the numbers for stress. So these are numbers that I would call really quite good. Generally, the rule of thumb, it's just a heuristic, it's not hard and fast law, is that as long as kurtosis and skewness do not exceed plus or minus 3, then you're probably okay. Having kurtosis and skewness at 0 represents normality. If you have exactly 0 for skewness, then you have a perfectly symmetrical data set. And if kurtosis is 0, then it's normally peaked. Negative would mean it's a little flat. Positive would mean it's a little peaked, which are, of course, platy and leptokurtic, respectively. So, the stress might not look perfectly normal in this distribution. We have a couple outliers on the extreme end, maybe obviously some positive skew here. And in fact, we can see that the skew is positive right here. It tells us that there is this little bit of positive skew to stress. But none of this is really extreme. There are tests, the Kolmogorov-Smirnov test, other types of tests that people use to evaluate whether or not a distribution is normal. We're not going to spend too time doing normality diagnostics in this class. But all that to say, before you decide to standardize scores, the assumption, of course, is that the scores are already normally distributed and that you are just turning these normally distributed scores into a set of scores that is standard normal. So we're going to go ahead and do that, assuming that our data is in fact normal enough based on the evidence that we've seen in the histogram, the skewness and kurtosis. We see that it's clearly unimodal. And again, the only things we had to worry about are modality, skewness, and kurtosis when we talk about normality. It's unimodal, it's relatively symmetrical, relatively normal in kurtosis or normally peaked. So all those things tell me the data is pretty well normal.